Looks like we're good. Alright everyone, welcome back. Hope you guys had a great break. It's been, what, 3 weeks now since our last one? So I'm going to do a couple of recaps on what's going on here. The last thing that we did is we started working on some basic collision in the game, and we were using some built-in rectangles to do that. So going back to a couple of slides ago, we had this little method which is called isColliding. It was very basic, but I just want you to remember what was going on here so that way you know what's getting called if you forgot. We were creating rectangles around our objects and then just checking if they were intersecting using the built-in methods. Ideally, you guys should be right here where you can shoot your enemy and something happens to him. So what I did for mine was making him jump. So the next thing that we're going to move on to is a little bit more advanced collision. Rather than just checking if two things are touching, we want to be able to figure out how they're touching. So you want your person to interact differently when you're running into a wall than you would if he's touching the ground. So if you're running into a wall, you want him to stop moving sideways. If he hits the ground, you want him to stop moving up and down. So the first thing that we're going to do is put in some walls. So if you guys have not done so already, go to the Google Drive page and download the block texture, which I'll put that link up on here again. It's 32 by 32. Does everybody already have this downloaded, or is there someone that still has not downloaded this texture yet? Still haven't downloaded it, right? I think it might be 5. It's basically. Once again, if anyone ever wants to redo art for this, it's more than welcome. Alright, does everyone have it all set? Alright, so hopefully you dropped it into your assets folder. We've done this a million times before, but I'm still going to cover it just in case. We're going to load up our texture object. So if you scroll all the way up to the top of your jelly class, or whatever you called it, we've got 2 textures already, which first one's for our player, which was defaulted to called IMG. The next one was for bullets, and then you're just going to copy and paste one in here. Basically, that's a block texture. So in the same way that we created our block texture then, just go down to our create method, which is where we want to load it up. And load it up just like we have any other textures, which is by specifying that's called block.png. Is everyone all set? Is there anyone still doing this? No? Awesome. Alright, so now, in the same way that we had an array of bullets, it'd be nicer if we had more than one block in our game. So we might as well store those in an array as well. So go right under where we have bullets, and we're going to do the same general idea where we can have an array of some giant number. Then we also have to keep track of how many are in there. So I believe at this point you guys have probably heard of array lists and linked lists. When I was originally doing this, 11.21 had not taught that yet, so that's kind of why I'm teaching this approach, but we'll go in there and fix this later on. So what we're going to do is we have an array of characters, since all blocks will also be characters. And then we'll set that to 1,000 because it's a giant number. And then make sure that you set block count to 0, which basically says how many spots in our array are actual blocks and not null. Is there anyone still working on this? Once, twice. Alright, so the next thing is we're going to create some blocks. If you guys are in 1121, you're probably working on a level loader where you have to read in a text file and build a level. We're going to be doing that today, but to start out, we're going to just hard code create 2 blocks. So somewhere down in your create section, I did mine right under where I defined my enemy. Just make two blocks, put them in the first 2 spots of your array, so 0 and 1. And then assign them some positions. Make sure that they're aligned to a power of 32 or something. So what this would do is it would create 2 blocks near the middle of my level, one stacked on top of the other, and that's all it is. Oh, and also make sure you set bullet or block count, to 2. Because if you do not set that, then you'll create blocks, but when we make a for loop to loop through them, it'll never actually update them or draw them. As a future reference, anytime that you're hard coding something in, that means you're probably doing something wrong. So this is just a way to teach you, and then after this we'll actually dynamically load things in from a text file. Is anyone still working on this? Once again, collision is a very tricky thing to learn, so if you guys have any questions, raise your hand. Someone will help you out. Is all set? Awesome. Alright, so now if you were scrolling through where we have our enemy and our player and our bullets, you'll probably notice that we were updating things. However, update pretty much just applies gravity and it makes things fall, and right now we don't want to have our blocks falling. We'll get into that way later on once we start getting into putting physics in our game, but that's very far off. So right now we just want our blocks to, wherever we put them, that's just where they're going to be. They're going to stick there and never move. So we're not going to call update. However, we just added our blocks, so we might as well draw them so that we know they're there. So if you scroll down to our draw, you should see a for loop where we're drawing all of our bullets. You can more or less copy and paste that code, except be careful when you're renaming things. There's block count instead of bullet count. You want to draw our block texture instead of our bullet texture, and you also want to draw our block X and block Y. Might just be safer to type it up fresh. Is everyone all set on this? Anyone else need more time? All right. Once again, feel free to experiment on your own. If you want to add some more blocks in other locations, it's never going to hurt. You're going to learn by messing around with things that already exist. Alright, so if you go ahead and run this, you should see that the blocks are drawn. Depending on where you put them, they'll be in different places. I drew mine on top of each other. You should be able to walk through them because we didn't apply any type of collision, so right now they're just pictures on the screen. Alright, so now we're going to break down collision into two different parts. Before, we were just being able to check if something overlapped. While that is very helpful, we need to figure out how they're overlapping. So we're going to handle colliding with walls rather than we will the floor. So the first part is, it's actually pretty easy. So in here, you should be able to see your little texture. And no matter what way you're touching it from, you should be able to tell if you're colliding. So one of the most common ways to go about doing this, I think this is animated. Oh, all right. So watch this because it's animated and I'm only going to play it once. So, oh, no, psych, never mind. So, yeah, you're standing here. All you have to do is check if you're colliding, which we're not. Here we are colliding. So if you are colliding, all you have to do is then move them back. So there's that real simple thing, which is move, check for collision, move back. So that's kind of how things work. If you're not colliding, you don't have to move backwards. This is something that I see very wrong all the time, where people will try to do some different way and they'll try to handle things in their own way and colliding doesn't work. People will like stick to walls or something like that and it's not fun to fix. Oh, so here's the animation. So you're starting there. Each time you move over and as soon as you collide with it, you just move back to where you weren't colliding with it. And that's how it works. So once again, this is a very basic form of collision. So if you are slightly further away from the wall and you move into the wall, you'll be slightly far away from the wall when you move back. However, it's something that you won't notice right now. There's better ways of doing this, but this is the easiest way. So this is the logic that I was saying, is where you want to move, check for collision, and move back. So this is what I'm going to break this down into. Is we're going to create a method because it's kind of its own little chunk of code here. And you just say move, and then there's an amount. So right now, we have it set up so if you're hitting the left arrow key, your player just automatically moves his X position left or right, so depending on whatever arrow keys you're hitting. So now we're going to change that to where when you press an arrow key, it's going to call this move method, where then move handles collision, so then you don't have to worry about it. So whenever you're moving, you just have to pass in an amount, where a positive number should move you to the right, and a negative number should move you to the left. So this is very similar to what we were doing before, is it just X position does plus equals amount. So if you give a positive amount, your X will get bigger, you'll move to the right. Then what you do is you check right here if your player is colliding with any block, and if you are, just undo that code where it says X position minus equals amount. So that means if for any reason you're hitting something, you're going to move back to where you originally were, which is guaranteed to be safe because you weren't colliding there. So now let's go ahead and implement this. I want to see if I'm adjusting this. All right, yeah. So this is where we were originally moving. This is how I had mine. You might have had a different speed. I was just hard coding my X to be moved positive or negative. So we're going to create a method called move that will replace this. So leave that for now. Go ahead and jump to your character class. The reason I'm putting this inside of our character class is lots of things will be moving. So your enemy eventually will start moving. Your bullets will be moving. All of that kind of stuff should be calling this move method. So before we start handling collision, we're just going to replace our old code that we had in here with this new updated stuff. So anywhere in character.java, I think I did mine near the end. I don't know where I did it. You guys might not even have set X velocity. I can't remember what I did and what didn't. Anyway, just put this somewhere in here. Public, because we want to be able to access it from outside of a character. It's void because we don't need it to return anything. And then we're passing in an integer. I called mine amount, which is just how much we're moving. To keep it very simple, all we're doing is updating our X position by that amount. So that's where I have the plus equals amount. If you pass in a negative number, that'll subtract. Oh, did anybody need more time on the previous thing? No? Okay. So now you can just swap these lines of code out directly. So before we had myCharacter.x equals myCharacter.x minus 3 or something like that. Now we can just type in myCharacter dot move and then pass in a speed, which would be, in our case, -3 or +3 or whatever speed you decide to make a move at. Now, ideally, if you did this correctly, you should do the exact same thing that it did before, but now we have a nicer way of doing it. So if you go ahead and test this out, make sure that your character is moving, that you don't have like 2 left buttons or 2 right buttons, or forgot to copy something over. Make sure that you can still move your character around just as well. Does anyone need help getting this far? Alrighty. Now we're going to finish our move method. And this is where it gets a little tricky, but if you break it down, it's very simple. Going back to that pseudocode that I had, which was a 3-step process, we're going to move, check if we're hitting something, and then move back. We're going to actually put that into code. So we already have our first part right here, which is move. So we can leave that as it is. Now for the hard part or the tricky part, is checking for collision. So this is something that will give us an error. So type it up like this, but you'll notice that I'm getting a couple of errors, and I'll show you how to fix that in just a sec. But in a perfect world, we'd be able to loop from 0 to block count, where block count is how many blocks we have that exist. And then we can do an if check right here, which is just if we're colliding with that block, then we can move ourselves back and stop. Now these variables, this is also in character, so these variables do not exist. They only exist in our game object. So I'll show you how to access them in just a sec. Does anyone need more time? All right. So the reason that we can't access these is because they do not exist according to a character. So they do exist, however, in the game object or jelly object. So this is a kind of my attempt at a visualization of this. Our game object has a bunch of properties to it, or objects in the game. We have an array of bullets, we have an array of blocks, we have our player, we have our enemy, and there's going to be a lot more stuff to come. And if I wanted to, say, access the 5th bullet or something, or the 6th bullet, you just call bullets at index 5. I could change the X position, set it to 10. That's very easy because the game has permission to edit anything that it's got inside of it, any of its properties. However, if I wanted to maybe say that I want one bullet to modify another bullet's position, you can't, because it doesn't know how to get from this one to this one. It only knows itself. So a very common solution to this is to make every object in your game aware of the game itself. So if, let's say, this bullet, let's say every object now has a way to get back to its game object, its parent game object, then from there you can access anything within the game. So for example, if I wanted this bullet to modify another bullet's position, I could get a reference to the game, and then from the game I could just do .bullets.x equals 10. So now where is this game object coming from? Oh, also, the same way that you can pretty much, if you had a reference to the game object, now this is where we actually care about it, is we could have our player access the game, and then from the game we could access the blocks, and then we could check if we're colliding with a block. So that's kind of our goal of passing this through. So in order to do that, we have to create a reference to the game in our character. So whatever your main game class is called, mine is called Jelly, create a variable of type Jelly, or your game, and then have a reference to it. Now, common names for these are either parent or game. This is very, very well used in like major game engines where everything has access to its parent. So from any point in the game, from any line of code, you should be able to access any object in the game. That's kind of the goal. Gives you a lot more power on your end. So after you've added this, does everyone have this? Does anyone not have this? All right. Now from there, that's just a object. It doesn't actually point to our game, it just is a game, and it starts out as null. So we want to be able to point to our game, the actual game itself. So the way that this is usually done is by passing in a reference during the constructor. So currently you should have our character says, if you want to be able to create a character, you have to pass in an X position and a Y position. And now we're going to require one more thing, which is a reference to the game. So now, before you can create any character, you have to pass in a reference to the game. The nice part about that is, whenever you have a character object, now you know you have a reference back to the game. So that means every character object can access anything. So the way that you go about doing this is by setting our parent, which is what I called the previous variable, which is our class level variable, equal to whatever this is. So depending on if you have the same name or not, you might want to put this.parent. All right, so now we have these two parts here that are giving us errors if you scroll back down to our move. So now if we want to access our block count, that's very easy to do by just typing in parent.blockCount. So now we have a reference to our parent, and from there we can now access the block count. Same thing goes for the parent.blocks. Just by sticking parent in front of it, you have access to those variables now. You could even access yourself if you wanted. Instead of typing in this, you could say like parent.myCharacter. You could go in an infinite loop if you felt like it, like parent.myCharacter.parent.myCharacter, and go on forever. Does anybody need more time on this? So this fix gives you quite a bit of power when it comes to accessing other objects in the game. Okay. Does anybody not understand why I passed this game object in? I'm just going to pretend that someone raised their hand. So this is huge, huge, huge in game design. I've seen way too many games try to duplicate code. Maybe they're copying and pasting things because it exists in one place but not another place. If you ever do something once, you should never ever have to copy and paste that. That's horrible practice, because maybe you have collision checking in 5 different places, and then you decide that you want to change it in one place. Now you changed it there, but the other 4 places still have your old code, and then these bugs start happening, and you have no idea where they're coming from. So being able to access a game object and have everything go straight from there will make your life a lot easier. If you're ever doing something twice, that means you're probably doing something wrong. So now, if you save this file, it's probably going to give you a bunch of errors in your main game class. And the reason for that is we just changed our character constructor, which means that for us to create a character, you have to not only pass in the X and Y position, but you also have to pass in a reference to the game object. So luckily all of mine were close, so I could fit them all in one screenshot. These are the positions that I'm passing in. And I'm going to go back a couple of slides here to where I changed my constructor. Depending on what order you put your constructor in, that will be the same order that you put yours in. So I put mine as my game first, and then my X and Y. Some people do it the other way around. So whatever you do, you're going to have to fix that by doing this. So you can access your own object, yourself, by using this. And since this is all object-oriented, your game itself is an object. So if you ever want to access yourself, you can just type in this. So when we're creating a character object, if we want to have reference back to ourselves, or back to the game, you just pass in this. Alright, so now test it out, and hopefully you can run into the walls and it should stop you. Keep in mind that this is only side-to-side movement, not up and down movement, so they should work as walls but not as ground. Does anybody have this not working? Because this is something very important for later on. Is everybody all set? Yep, because if you think about it, the reason that you can fall through it right now is because you're only checking for collision when you're moving side to side. And if you are hitting it, it will only stop you from moving side to side. We're only messing with the X collision. So if you stop and just drop right through it, it doesn't matter because you're not hitting the arrow keys, which means you're not calling move, which means you're therefore not checking for collision. So usually when you're doing stuff like this, you want to break up your collision into two parts. And this is one of the biggest mistakes I see is where people try to do one fatal swoop of moving everything, checking, and then moving back. And the problem with that is then you get some really weird errors where, let's say you're colliding with a wall. If you collide with the wall, it'll move your character back to wherever you just were. And then you collide with the wall, move back, and it moves, technically you're jittering back and forth, but according to your game, it feels like you're stuck to the wall. So you should always handle up and down collision separately from your side to side. So that way you can tell if you're hitting a wall or if you're hitting ground or a ceiling. So that was the end of this one. We were halfway through that one, so pick up the next one, which is part 2. Yeah, so this presentation is pretty complicated. We got collision, level design, error handling, lots of stuff that's going on here. So this is probably when your game starts to seem like a game. I think I've said that every week, so we'll just keep that up. So yeah, this is where we left off. Alright, once again, all of my checks for collision, I'm trying to keep them very simple. There's very, very complicated, very efficient ways of checking for collision. If you guys are honestly interested in them, I was doing a lot of research over this summer on collision detection, so I learned a lot of really cool things, but they get very ugly very quick. So, ground. I've seen a lot of people try to sit down and pump out collision in one sitting without thinking about it first, and whenever you're making a game, you really need to get away from the computer, come up with an idea, and then make it a reality. Because if you're starting to throw variables everywhere, you're going to end up with some things that might work, or at least seem to work, but are actually causing errors somewhere else, or you'll just be completely stuck. There's a lot of really weird things I've seen happen in games where maybe people will touch a wall and then they'll like fly up because, I don't know. So make sure that you really think this through before you start. So this is your chance to watch right now. I'm going to show some code. Don't actually mess around with this. I'm going to go through and modify update. So let's see. Yes. All right, so this is what I'm doing is in update, we start out by updating the X velocity if it's a bullet. We update the velocity due to gravity to make you fall faster. Then we update our position to make you fall itself. Then here you check to see if you are touching the ground, and if you are, then you stop falling. And then here is my newly added collision code. So all that does is the same thing as move, kind of, where it loops through for all the blocks, and then it checks if you're colliding with a block. And then if I'm colliding, I decided to just stop moving, which is set my velocity to 0, which means I'm no longer falling. However, when you try this, this happens.
It's good poke quicksand.
So this is one of the most common errors I see. I see this absolutely all the time. So do not do this. So now the reason that this is happening is because if you walk through your code, we're updating, here we increase our velocity, which is just a little bit, so like 0.01 or something like that. Then we move ourselves, which might just be a little itty bitty bit. Then we check if we're hitting something, we move back, and then here we reset our velocity. So now what would happen is if we were actually colliding, as soon as we hit, we say we're colliding and reset our velocity to 0. But then as soon as we loop through the next time, it increases our velocity, moves us just a little bit, checks here that we're hitting something, and resets the velocity again. So what that does is make you seem like you're moving very, very slowly through this, like quicksand. So another error is people see this and they're like, oh, I just need to reset my velocity before I move myself. So update my velocity due to gravity, run this check so that way if I'm colliding with something, I don't accidentally increase my y velocity. So that would be what people decide to do. So they move their code. So going back to the same strategy is update the velocity. If we're touching something, stop us from falling. And now we finally update our velocity here. Problem is you get this. You get stuck. So as soon as you jump up there, you'll kind of notice that he sinks into the block just a little bit, but then is stuck. So no matter what he does, he can't get out. Even if you try to jump, you're stuck. And the reason for that is, I don't really explain it in the slides. So the reason for that is as soon as you're colliding with something, we stopped ourselves, but we're still colliding with it. So a lot of people don't reset their position. So when you're colliding with something, you don't want to just set your velocity to 0 because now you're still colliding with that object a little bit, which means that you're stuck, and even if you try to jump out by setting your velocity super positive, you still can't get out. So now this is what we just did, was where we're falling a little bit, and then as soon as we collide with it, we stopped and we said set our velocity to 0 and don't move him. The easy way to fix this problem, which is very commonly used actually, is all you have to do is check if you're colliding and then reset him to a position that you know is safe. So this is the same thing as moving side to side, where we check collision, move back if we're colliding. So wait until he's colliding. As soon as he's moving, colliding, just undo whatever you just did. All right, so now this is code you should actually type up. So what we're going to do is we have our y velocity. We're leaving that the same, where we increase our y due to velocity. And after that, you can kind of copy and paste this from earlier, where we have our move section, that for loop that loops through all the blocks. That'll make your life a lot easier. Wait for you guys to get this typed up before I start explaining it. All you have to be adding is this for loop. Everything else should already be there.
No, that's already there now.
Why does that move? Oh, it's okay.
All right, so even if you're not done, I'm going to start kind of going over what's going on here. Is what we are doing is we are increasing our y by velocity. So following the same logic is we move, then we use this giant for loop here to check if we're colliding with something. And then all you have to do is undo whatever you just did. So what we did here is we updated y by velocity, which means to undo that, we just do y minus equals velocity. Make sure that you do that before you reset your velocity to 0. Because if you do it afterwards, you will not undo your velocity itself because you'll be subtracting 0. Also, make sure that you set your velocity back to 0, otherwise you'll be moving back and it'll look like you're stuck. However, your velocity will still be rapidly increasing, which means that even though your player looks like he's not moving, he's still falling extremely fast. So make sure you reset velocity to 0. It's always a weird thing when you sit there and you like fall onto a platform and it looks like you're stopped, but then as soon as you move off the platform, you immediately fly down really, really, really fast. I see that a lot as well. Does anybody else need more time on this? All right.
Do you like to do like a stutter stop? There's like a stutter stop. It's like he's sinking into jelly actually. On the edge it falls through? Huh. That's weird. Like you go off the edge and then fall through the blocks. Yeah. Like you can't? You left and right? Messed up then.
I think it's only colliding.
You're always colliding?
They work, my left and right, we're working just fine.
I have no idea. It's so weird. Everyone's having these weird errors and I don't know what's going on.
Is it because of this one?
Y plus equals velocity.
Can you see your character thing?
Let me see your Euler.
Is this in the right place?
You put it above falling the ground. Hitting the ground. That one.
Right there?
Yeah, that's right.
Can't move.
Why can't you move?
I have no idea.
Did you accidentally change something in your move?
I just checked it.
Wait.
That is the exact thing.
It is. X minus equals velocity. Wait, what?
I still can't move.
Oh, why do you still have your...
What? You got me.
Why is it direction you understand?
That's how I shoot moving.
Maybe it's that.
No, it's just an integer. Maybe it's something from down move then.
Your move is identical to mine now.
Wait, should this be within update?
No, it's a separate number.
Should this be X?
Yes, it should.
Okay.
There we go.
I counted out.
Oh, okay.
You're right, you guys
Yeah. That safety field. Yes. Yours doesn't do it. You can't do the cool thing. Watch. Do look.
The,
Bleh.
I turned that off.
Alrighty.
Oh, no, the screen's so small.
So now hopefully that should work for you. You shouldn't be sinking through it. It should seem like it's real ground. So now your block should be impossible to go through. However, keep in mind that your bullets can still go through them. The reason for that is because they don't call move, but we'll get to that in a sec. So a couple things to notice. One is that make sure you're testing your games out, because these are just weird things that go on. It might seem weird to you. Why are you able to collide with it but nothing else does? So the first thing is that bullets go through, which I don't think we fixed for a couple of presentations. The next one is when you get to the ground. This is kind of exaggerated, but if you look really closely, you can kind of see your person slow down right before they hit the ground. So the reason for that is because of this right here. You start out, you're falling, then you're starting to fall faster, and then you start falling faster, but then at this point it checks and it says if you move there, you're going to collide with the ground. So then it does what our code does, which is telling you not to actually move, but then it resets our velocity to 0. So now it's like we're starting here. This is all exaggerated a lot. But now it seems like you are up higher and it looks like you stopped. However, you can now update your velocity just a little bit, and that's okay. So you start falling a little bit. You update your velocity a little bit more. You can keep falling. You eventually get to here, and it says that you'd be colliding, so it does the same thing. It resets your velocity to 0. So then you're here, and it moves you down a little bit. So it's kind of like you're hitting the ground 3 times. So this is something that is very, very subtle. You probably won't ever notice it, and believe it or not, if you actually watch a lot of 2-dimensional games, and sometimes even 3-dimensional games, look really closely and you'll actually see this happening a lot. And the reason for that is it's very easy to code this up, it's very efficient for the code to run, and it's a bug or something, I don't know what you want to call it, that is very difficult to notice. So once again, the reason I stuck with this one is it's very easy to implement. If you want to learn how to avoid this, once again, you can talk to me and I'll walk you through it, but it's very ugly. So that's kind of why he is falling and then slowly lowered down. Alright, so on to our level design. This is something that you actually have to do for your 1121 homework. So right now we are creating our blocks hard-coded. This is not a good idea to do. So now something that's very, very common and very easy to do is to make a text file, and we could build our level in there, have our program read it, and build our level in the game. So I decided to go with 0s and 1s. And also a quick note is the libgdx window is 640 by 480 pixels. And since our blocks are 32 pixels wide and tall, that means that we can have 20 blocks wide, 20 or 15 high. Yeah, I suggest using something other than Windows Notepad. The reason for that is new line characters. You'll see that later once our game starts editing levels, but you can use whatever you want for right now. Actually, you can use Eclipse. I completely forgot that Eclipse is also a text editor. So use that. So go ahead and go to right-click. I don't think I have this on here. Oh, so yeah, this is what the level would look like if I loaded it up. Alright, if you can see my mouse on here, go to the side of Eclipse, right-click up on the very top, right on Jelly Jumper Core, or Jelly Core. Right-click on that, hit New, and then hit File. Completely forgot Eclipse has a built-in text editor when I was doing this, which I feel very stupid about. So it's going to ask you for a file name. Call it level.txt. The .txt actually doesn't matter, but it just tells the person that it's a text file. So you can make your own file extensions if you want. You can make it level.level or level.iroc or something. So after you get that, go ahead and I'm going to give you a sec. Once you have it, just load up something like this where it's 20 blocks wide and do 15 blocks, 15 lines tall. So I would suggest using 0s and 1s. I would also suggest spacing them with or padding them with a space. It makes it a lot easier to parse through this later on. However, you are the designer, so you can make your own format however you want. Like people do commas to separate it, which is another common format called CSV, which is comma separated values. Maybe you want to put everything on its own line. You can do whatever you want. You can use numbers, letters. It's up to you. But for the sake of this, you might just want to do what I'm doing. It'll be a little easier. What was that? Yeah. Another thing is a lot of people have come up to me and said, why are you doing it with ones, zeros, and spaces? You're doing a lot of empty, wasted space. If you know about bits and stuff, each character that you have is 8 bits. And if there's only a block or not a block, why am I wasting so much space? However, when you compress a text file like this, it compresses very, very well. So even though this might be a larger file, when you compress it, it'll be nearly the same as what everything else is. And the nice part about this is you can read it as a human, and you don't have to open it up with some special level editor. Probably should put a link to this on the site. Yeah, I'm going to do that right now, actually.
It's 20 wide?
Yeah. Yes.
20 wide, 15 tall.
Use the clips like some number lines. That makes things kind of cool.
Yeah, I'll have it up as soon as you guys are done. I'm going to toss it in the assets folder. This is also not the same level I'm using. I like to change my level ups because it makes me feel like I'm changing the game. So every once in a while I switch how the level looks. So yeah, if you don't want to jam the keyboard, you can go ahead and download that from the assets folder on Google Drive and plop it into your game. Keep in mind it's not in your assets folder according to the game. It needs to be in the root directory, not the assets folder.
I just copy and paste it.
Yeah. That also works. Alright, so now the next part, try to finish this up quickly here, is the actual logic for loading your level. Probably won't get to finishing this. But the easiest way to do this is to not put all of your code right in the main class of something, because loading your levels can be very, very simple, or it can be very difficult. What was that? Oh, I'm not going to finish this whole thing, but at least the level design. So I would suggest making a method called load level or something along that lines, which you can then call once up at the beginning of your game, so that way when you're reading your code, you see load level and you know what it means, rather than looking at this and seeing a bunch of for loops and a bunch of weird symbols and stuff like that, because this is one of the most confusing things to look at later in your game when you don't remember what it was. So create this load level in your jelly.java file. You can create this anywhere. I put mine near the bottom because I don't like to look at it.
That bodes well.
So now, how do you read from something? So you guys have probably all seen scanners before, where you read from the command line, which is scanner equals new scanner, and then system.in. That reads from your keyboard, basically. So now if you want to read a file, all you have to do is, scanners luckily can read files. So you can create a file object like this, which is file. You can call it whatever you want. And all you have to do is pass in the path. It doesn't even have to be a TXT file. You can name it dot whatever. The dot doesn't mean anything. And then to load that up with your scanner, you can just say pass in your file, and then it will read your file instead of your keyboard. So go ahead and create this little combination here right inside of load level. You're going to have to import both of those. I didn't say that as well. If you haven't imported file and scanner, I believe file is just java.io. I'm going to try to pick it up here a little bit, so if you guys get behind, just look at the slides. You should be able to finish it up. So we have scanner equals new scanner, and then we're passing in the file. So now it's going to give you an error, and it's something that you're not going to see when you're doing system.in. And the reason for that is I didn't say that. Well,
It says a little tiny part right bottom of
oh, the previous slide? Ah, yeah, so what happens if level.txt does not exist? So Scanner is kind of giving you a warning saying that there's a chance that you're trying to load a file that does not exist, and if that happens, your game will crash. Well, it won't even compile in the first place, but... So the solution to doing this is there's two solutions. You can basically say that something throws an exception, which we'll cover way later on. The alternative is I'm a bad programmer, so I'm surrounding everything in a try-catch block. So, if you guys do not know what try-catches are, they are basically a little section of code that you section off, and you tell it literally to try to run this part of code. And if anything ever crashes, it jumps right down to this catch block. So you start out with a try and then a squiggly bracket. And I believe if you hover over the error that it's on there, it says like surround with try catch. So you can just click on that and it'll automatically handle this for you. And what this says is if there is this exception of type exception, I called mine E, if anything happens, it immediately stops where it is here, jumps down to this catch, and then continues going through your code as if nothing happened. So a lot of people like to use these everywhere, but you should be very careful with them because if you ignore errors, then you're probably going to make bigger ones.
Also, they make your code really ugly.
Yeah, they make your code pretty ugly, actually. So now I'm just surrounding absolutely everything in this try. So I kind of accepted the fact that if the file's not there, my whole level's not going to load anyway. I'm not going to try to spoof a level real quick. So what you have to do now is you have to basically read in this file. And I decided to read mine in line by line, where each line will correspond to a row on the level. So in the same way that you can read from your standard input from the keyboard, you could do scanner.hasNextLine, and that will continuously loop until there is no more lines after that. So I threw that in a while loop here, which in our case will read the file line by line until it hits the end of the file. So this should run exactly 15 times, assuming that your file is 15 lines long. Then for every one of those, I read in a string, which is just that specific line. So using the scanner.nextLine, I just load up that one row from our text file. So if you guys are in 1121, you might have been using next instead of next line. All of that's fine as long as you can dynamically read something in. So if you guys are in 1121, I think the first line was your width and height of your file. Even if you don't have that, you can still figure that out really easily. You can figure out the height because you just keep reading until there's nothing else. And you'll be able to figure out the width by doing this. I'll get to that in a sec. So now we have just this one line, which in this case we have this string, which is a bunch of zeros, and then it finishes with a 1. So now we want to be able to access each one of those. A very common thing that you'll see is a method called split in Java. It's very handy. So if you call split, you basically pass in a delimiter, which will then split up the string into an array based on that. So right here, right under where I read the line in, I made an array of strings called block. And I think I used a very bad naming scheme here because now I think we have block, block, and blocks, like 3 different variables that are all the same or nearly the same. And then you can easily just access that by saying line, which is our line that we read in, our string variable, dot split, and then in these parentheses you just put a space. So you can separate these by whatever you want. If you want to do comma separated values, you use a comma there, and it's very, very simple to do. Just going to keep chugging along here. So now what happens is we have this string line here, and after we call split, now we have this array called block that has however many number of data points. So it all depends on how many there are. If you decided to make a line that was longer than all the rest, this would split it up as well. You don't have to specify a size. It will handle that all on its own. So now we have a bunch of strings that are either 0 or 1, or if you type something in wrong, it's going to be that. So this is a lot easier to use to decide what block we want to put where. So in my case, I decided to say 1s represent a block and 0s represent nothing. So we're going to have another loop. So we have our while loop, which loops through our rows, and then we're going to have a for loop here that loops through our individual blocks of that row. So the easiest way to loop through all of those blocks, we're going to loop from 0 to how far? Well, we're just going to loop through however big that array happens to be, which will be block.length. So now we are basically looping through every single little data point in that file, and now we can check if it's either a 0 or a 1. So inside of this for loop, I'm doing one little check, which is checking if that specific block at position I, so that point in that data that we just cut up, that should either be a 0 or a 1. So if it's a 1, I'm using dot equals here. Keep that in mind. It's a string. You cannot use equals equals, the double equals symbol, because it doesn't work for strings like it does for numbers. And even though this is a 1, it is still a string. It is not the number 1. So if it equals 1, we're going to create a block. So I think I do that on the next slide where we actually create the block. Yep. So in order to create a block, it's very similar to creating a bullet if you think back, where we create it. We store it at position block count, where block count starts out at 0, and then it goes higher as we make more blocks. And then a block will still be a character just like anything else. And then I have 3 variables that you have to pass into every character. The first one is going to be a reference to the game object. Since we are loading this from the game object, we can just pass in this. Then you pass in the x position, which in my case, I'm doing a calculation here. I'll get to that in just a sec. And then you also pass in the y position, which is going to be another calculation. So where did this I times 32 come in? Well, the reason I'm doing I times 32 is because the width of our block is 32 pixels. If I want the first block to be in the lower left-hand corner, or the left-hand side of the screen, that would be at position 0 for the x. The next block would then have to go at position 32, which would put it side by side. The next one would have to go at 64, and then so on, every 32 pixels. So, if we want to know how many blocks over this block is, we have I, which tells you which is what we're looping through. So in 0, it means we're looking at the block all the way to the left, and ideally it goes all the way to 20 to get all the way to the right. And also I'm passing in 0 for the y, which means that it's basically going to put everything all the way on the bottom. That's because y is a little bit trickier to calculate. It's not just a simple multiplication. So now we have this wonderful load level method, and if you want to actually use it, all you have to do is go to where we hard-coded our level. There's 3 lines of code there, which is where we created the blocks and then incremented our block count. You should just be able to replace that with our little method called load level, and everything should work fine for you. Alright, so this is, where is our level right now? I don't know why I did it this way.
You wanted us to be all set.
I think I put this into my assets folder. Hold on. I don't remember making this slide.
Yeah, it's not. It's not in.
Ah, alright, yes. Now I remember why.
I don't think we rendered it.
Nope, it's... Alright, so I'm going to kind of fly through this. If you remember, we had our try-catch block, and the reason that I did this was because I wanted to show you what kind of weird errors are going to happen. You might feel like you just didn't draw them at the right place, didn't position them correctly, you're maybe not drawing them. However, let's if you add this little line here, e.print stack trace, it prints off the information about your error if you hit one. And when I did that, I ran it, and it tells me this: level.txt cannot find the system cannot find the specified file. And the reason for that is because I put it in the wrong location. So when you're running your game, it has to be relative to wherever you're running the game from. So since we are running the desktop version of the game, we need to have that file in the desktop version of our launcher, not our core file. So keep that in mind whenever you're porting this over. Like if you decide to make it for Android, you need to have a separate level file for your Android as your game itself, or as your desktop game. So the easiest way to do that is literally to just move it over, drag it from our core file to our desktop file. Oh, and then I also cover why your assets don't cause issues when you put them in your core file. That's because if you see this little linky thing here, that means that you're not actually putting it into, or if you see on the desktop, where is it? Here, you see the little symbol there, which basically means that it's a symbolic link, which means it's accessing it from somewhere else. So even though you're dropping things into your assets folder in your core, your desktop still looks to your assets folder from your core. It basically creates a copy of it.
Where are we supposed to pull that to?
So hopefully, you put the txt file, you move it from the core down to your desktop. So, nope, it's not going to be in an assets folder, it's just right in the root directory. So not in your src folder, not anywhere else. This is where I'm going to break it off here, is if that worked, you should be able to see your level loading, except it's only going to load on the ground. There shouldn't be any vertical stuff. We'll have to fix that next week.